Good morning, everyone. My name is Minh Dương Nguyễn. Today, I will present our work titled Federated Unlearning via On-Server Gradient Conflict Mitigation and Expressions. This work studies federated unlearning, where a trained federated model must remove the contribution of specific clients after training. Our key idea is to prepare the model for unlearning during the training, then perform efficient unlearning directly on the server without the full retraining. This presentation has four parts. First, I will briefly introduce federated unlearning and the limitations of existing methods. Then, I will present our proposed framework full. After that, I will explain the key idea behind our gradient mitigation strategy. Finally, I will show the main experimental results. Federated unlearning aims to remove the influence of certain clients or data from a trained federated model. One straightforward solution is retraining from scratch after removing the target clients. However, this is extremely expensive in federated learning because it requires a repeat communication route and local training across many clients. Existing approximate methods improve efficiency, but many still rely on historical update, retraining procedure, or branding strategies that may also damage the useful knowledge from retained clients. Therefore, the main challenge is how can we efficiently forget the specific client while preserving the knowledge learned from the retained clients. Our work makes four main contributions. First, we propose a two-stage framework for client-wise federated unlearning. Second, during training, we disentangle the model into the causal components that capture the shared task knowledge and non-causal components that capture the client-specific knowledge. During the unlearning, we update only the non-causal branch on the server using the gradient conflict mitigations. Finally, we introduce the time to forget matrix that measures how quickly a method reaches effective forgetting. During training, instead of learning a standard monolithic model, we separate a model into two branches. The causal branch learns a domain invariant and task-relevant information that should be preserved. The non-causal branch learns the client-specific or domain-specific information, which becomes the target for the unlearning later. During the training, we optimize four objectives: reconstruction loss, causal loss, non-causal loss, and classification loss. Together, these loss organize the representation so that client-specific information is separate from the general invariant knowledge, while both of them will retain the meaningful information to reconstruct the data. During the unlearning, clients still perform local updates normally and send gradients to the server. The server then performs on-server unlearning using the gradient-based optimization. But importantly, only the non-causal encoder is updated. The causal encoder remains preserved to maintain the general model performance. This slide shows the core intuition of our method. For retained clients, we want the gradients to remain aligned so the model continues converging well on the retained knowledge. For forget clients, we want the gradients to stop contributing positively to the global update. Therefore, the retained clients' gradients are encouraged to form the acute angles, while forget clients' gradients are pushed towards the obtuse angles related to the retained client. In simple terms, retained clients continue guiding the model, while forget client becomes diametrically separate from the optimization direction. We evaluate full on multiple datasets and architectures. The results show that the full consistently achieves the better forgetting quality, the smaller performance gap compared with retraining-based reference, and lower computational and communication costs. We also evaluate the time to forget. Compared with retraining approach, full reach the effective forgetting much faster because it selectively updates only the non-causal branch instead of restarting the entire retraining process. To conclude, we propose full federated unlearning framework based on learning to unlearn representations and on server gradient conflict mitigations. Thank you for listening. I'm happy to take your questions.